many research are just sometimes read by the author, editor, and reviewers only. So like this platform will give opportunity for sharing ideas and exchange, and sometimes from the seminars and these webinars, new ideas are coming out. I will just focus today on this topic, application of remote sensing and GIS, mainly on how to implement these technologies in real life for professional in a very simple way, so that no need for theoretical or mathematical equation for them. They just need to know the basic of how to implement remote sensing and GIS. I will link this to the United Nations Sustainable Development Goals. And then since we deal with flood and rainwater harvesting, it's very important to highlight how rainfall estimated from remote sensing. Specifically, I will just give overview about two missions, the Tropical Rainfall Measuring Mission and the Global Precipitation Measurement Mission. In addition to that, I will show how GIS is applied and remote sensing in a real study case related to fluvial flood in Sudan, specifically around Sennar city. As we know that the United Nations listed 17 goals in 2015. With these goals, tried to encourage government, researchers, professionals to implement all of these goals. One of the initiatives also in the United Nations is to use remote sensing and GIS as a tool to help in implementation of these goals. Nowadays, many governments and even here in our university, they set a specific item for research and they support student, faculty, researchers to try to implement and align their research with any of these goals. And of course, as you have seen here, we have item number 6, it deals with water. Item number 14 also. And in link to this also, if we talk about zero hunger, we need water because water is very important for crops. If we talk about climate, water is also play a very important part. Even if we talk about peace, because water is a source of conflicts, not nowadays between countries, but from the past, we know that since people live in a nomadic life, they have problem with water. So water is becoming very important part in all of these goals. It may be around more than 60% of the item listed. We find water is one of the components in this. Water security and food security are at the top of agenda for any country, because for drinking, for agriculture, food security, animal, wildlife, all of these. I'm going to focus on rain and how remote sensing is used to estimate rain. Going back to the basic of meteorology, normally they use a different techniques to estimate rain. For example, like tipping bucket, set on meteorological stations. So what are the problems related to meteorological stations or the traditional method of measuring rain is that we have a limited coverage. For example, you put this tipping bucket or a meteorological station somewhere, it will measure rain only at that location. Other location, there is no measurement. And we have a problem with rain. It is not like temperature. Temperature you can estimate from neighboring location. But rain, actually, we did estimation and interpolation, but it is not correct because it may rain in a part of a city and the other part there is no rain. So normally we interpolate, but this interpolation is not correct. Therefore, to avoid the locality of meteorological station, they move to what they call it weather radar. The advantage of the weather radar, it gives more coverage, maybe up to 200 kilometers, and it is based on sending signal. If the signal hit drop of water, it will be reflected back. So the time for sending and receiving will be calculated, and the distance can be estimated, and also the reflectivity can be converted to amount of rain. Whatever hit here by the signal, maybe a drop of water or maybe ice, but sometimes also they face problem related to reflection from birds or maybe other insects. Also, they have limitation of 200 kilometers. That means beyond this. So there is also limitation related to the use of the radar. How to estimate the rain? This is a basic equation that is commonly used to estimate rain and to link it to reflectivity. Based on limitation also of this 200 and the coverage, people and scientists move to remote sensing. Remote sensing, there are many types of satellite that provide information about rain, and one of them is a tropical rainfall measuring mission. It is launched 1997 and ended in 2015. This is more description, but the most important item here is the inclusion of a precipitation radar in the satellite. This is a big move, and it is different from all previous satellites. In addition to that, it is also provided with what we call it microwave imager. The microwave imager will complement the precipitation radar to estimate rainfall in case there is gap related to spatial or temporal. After, maybe before the end of the tropical rainfall measurement unit, they launched the global precipitation measurement mission in 2014. This is more specification about the SWOT and so on. The advantage of the GBM over the previous satellite is that it can measure even light rain. The previous one measured only heavy rain around the tropic. Also, it covers large area. Initially, it starts from 65 degrees north to 65 degrees south, but now it extends up to 90 degrees north and 90 degrees south latitude. The satellite itself consists of also a radar, precipitation radar, in addition to other sensors, as you have seen here. But the advantage also, it combines reading and observation from other satellites. So all of the other satellites, they will send the information to complement the GBM constellation, so that some areas that are not covered by this satellite could be covered by other satellite. And as you have seen here, there are many space agencies such as NASA, JAXA, and so on. All of them, they are participate with their data to complement estimation of rainfall from satellite. Also, when we talk about global navigation satellite system, they are merely designed to give location, but they are also utilized to estimate rainfall. And this is the base, what they call it, zenith tropospheric total delay. Mainly, if we look in the troposphere, maybe from 0 up to 15 kilometers, we have clouds. So when the signal passes from the satellite, it may be affected, bending due to refraction. In the troposphere, we have many gases such as nitrogen, almost 78%, oxygen, 21%, and we have water vapor around 1%. So mainly they look at the water vapor and its effect. The tropospheric effect whether water vapor or other gases is considered bad for people who are interested in location, because it's considered one of the error, and there are many methods to remove this error. Maybe through what they call it virtual reference system. That means you have many stations in the city to estimate the amount of error and then broadcast this error, as we have seen in many cities around the world. But it can be used in another application, and this is now a health area of research. They call it Global Navigation Satellite System Metrology. That means it is an added value of the Global Navigation Satellite System to measure rain or to estimate rain. Also, the other methods that are currently used is to use mobile towers. As we know that the meteorological stations are very expensive and they are sparse. That means they are separated very far. But mobile towers are denser. We have more towers. For example, in a city, you may find 20, 30, 40, or sometimes maybe 100, depending on the telecommunication companies. So the signal send it from one tower to another tower. If there is rain, it will be affected. That means the signal level, it will be attenuated. This is also used to estimate rainfall. There are many research going on, and they get a good correlation between the observation from mobile towers and observation from meteorological stations. So they're the good idea. They're the good ways and method of estimation, because the accuracy will be more better, because we have a concentrated network of mobile towers in cities. Also nowadays, they move to use of artificial intelligence and machine learning. There is a special mission by European Space Agency and many other universities. They develop a model, they call it World Flood. This was launched just June 30, 6 macro satellites, and one of them, they carry this model. The basic idea of the model is to calculate rain in space rather than downlinking, because as we know that with CubeSat, one of the problem, downloading of the data, sometimes it may be very heavy to be downloaded. So if the process is done on board, that means computing done on board and just send the result, this will reduce the amount of data sent down to receiving stations. Still, of course, this mission just June 30, still they are in checking and deployment, but I did not find any output or reading from this. Also, the application of GIS, Geographic Information System, in flood and rainwater harvesting is well known, because GIS can combine many data, and we summarize this data, produce information like pattern, identify the pattern and knowledge. And I talk to my students, even old people, they use expert system, they use artificial intelligence from early time. The basic idea, if you ask any old guy, if he look at the cloud, whether it will rain or not, he can predict by 70 to 80% based on his experience. So they already use artificial intelligence, they use deep learning, they look at the cloud, they know the color of the cloud, they know the season, so they collect a lot of information, and then they will tell you, okay, it will rain today based on this. So GIS is considered very important. Also, nowadays, people move to 3D application of 3D, so you can integrate all the data in a city to simulate and to know where the areas that will be flooded, so you can take preventive measures to reduce the impact of flooding. I will highlight the study case in Sudan. This may be flood in Sudan is one of big issues that happen repetitively. For example, just in 2019, as you can see, more than around 500,000 people are affected. Around 50,000 houses are completely damaged, and some of them around 36,000 partially on different part of the country, as you can see, depending upon the season. So this estimation is based on the United Nations Office for Coordination of Humanitarian Aids. Also, if we look at the rainfall, mostly in Sudan, in middle center of Sudan and South Sudan, so that we have more amount of rainfall. That means all areas in this region, most probably they will be affected by flood. Estimation of rainfall, as we mentioned from satellite, help a lot because sometimes this area, maybe there is no meteorological station to measure the rain. So estimation from satellite will help to give a quick idea, and now it has become part of the operation of many meteorological organizations to include data from satellite to help in early decision making rather than waiting for meteorological station data, or sometimes there is no meteorological station at this location. What we want to do here is just a very simple way how to determine flood alluvial, that means close to the river, and how to harvest. So we have two different approach. One, we have surplus of water, and here shortage. So we try to keep a balance between, as in business mentioned, supply and demand. So the objective is merely to identify where the areas that most probably will be flooded, when, who will be affected, and why. This is a concept of alluvial flood, that means flood near the river. This is different than the normal flood. The difference is that in this area, at this moment, there may be no rain. The rain may be around 100 kilometers far away, but it is flooded. So this flood is merely due to the river. We are going to see why, because many people nowadays, they start to encroach, that means they build near the banks, and this is related to urban planning rules and so on. This is another way of how areas are flooded. This houses damages. Of course, this will cost families a lot of money, evacuation, costing, and so on. There are some flood indicators, they use it. For example, if the flow in the river reaches around 600 million cubic per meter, it means most probably the river will be flooded. That means we will have fluvial flood. Also, they have gauge level. If it reaches 17, it means flood. If it is 16.8 meter, it means a very critical. So they will alert the people who live near rivers to evacuate or to take precaution measures. The study in general fall within the disaster management. Mainly, we have 4 phases for any disaster management. That means mitigation. In the mitigation, we have to educate the people. For example, do not build near rivers, low areas, and so on. We have to understand the socioeconomic indicators such as income, gender, preparedness, response, recovery. And as we have seen here, there are many organizations involved at different parts of the disaster management phase. So the key is here communication. There is a need for communication between different departments. For example, meteorology, people who work in river management, civil defense, and so on. Coordination, building codes, because as we have seen there, some buildings, they do not satisfy or meet the requirements. Our study area, we take it just near Sennar city. It is around 300 kilometers from Khartoum, the capital. Why I choose this? Because of the availability of data. Also because of the importance of the dam. There is a dam here, called it Sennar Dam. It supplies water to Gezira irrigation scheme. This is considered the biggest irrigation agricultural scheme in Sudan. This is statistics about the average rainfall in the area. And normally we have flood in the Blue Nile during May, but it reaches its maximum during August and September. I give you just brief idea about Sennar Dam. It started before 1924, but completed in 1925 with a main objective of supplying water to Gezira agricultural scheme. This is just an image about Sennar Dam and how the development. If we compare the dam with other dams like the Grand Ethiopian Renaissance Dam, we find the storage capacity is small if we compare it with the Ethiopian dam, or we compare it with other dam like Croceri's Dam. But it is very important to the economy of Sudan. Because our studies mainly based on a scenario, what is the impact of the Ethiopian Renaissance Dam on the people in Sudan? It has some advantage, like it controls the flooding, it controls the sediment, because the sediment will accumulate it in front of dams. It is a problem, but on the other side, it is considered disadvantaged because it reduces fertility, okay? Improved depths of navigation. So there are some advantage and disadvantage of the Ethiopian Grand Renaissance Dam to Sudan. As we mentioned, Gezira agricultural scheme is near Sennar Dam. It is main economic backbone for Sudan. They grow different crops such as cotton, sunflower, wheat, and peanut. All of them, they represent economy for export and also for socioeconomic development. We use some data such as population, digital elevation models, roads, weather, and we use Sentinel-2 satellite image mainly because it is available free and with a good resolution in comparison to Landsat. This is maybe description about Sentinel-2 satellite. Maybe many of you already aware, but they are a twin satellite. The first one in 2015 launch and the second one 2017. And this more detailed. They have 13 bounds, different output product. So the user can select the ready-made, that means almost rectified. The bands, they have different resolutions, some 10, some 20, some 60. I'm not going to go in details, but this is available online for you. So what we did first, we classify the satellite image to generate the land use. We classify also the digital elevation model. We make buffer around the river to know which one is close and which one is far. And then we create weighted overlay in our GIS because these are different factors with different units. So we normalize all of them to a scale, and then we create the flood hazard map. First step in selection of satellite image, we have to refer to the rainfall pattern so that we can choose the best months where there is less amount of rain to avoid cloud coverage. As you can see here, this is during October 14 and here 19. All the area is covered by vegetation because maybe this is after a little bit of August, September plants. So we have to pay attention to the phenological cycle in selection of satellite image date that is suitable for analysis. We prefer to take the summer. It is the same area, but there is no vegetation cover and also there is no cloud. This will help us in classification of the land use. Another problem related to what we face is how to take training samples or signatures for water. Water, as you have seen here, may be more blue, so it is easy to take. This is in February, but if we look here in October, the water is sediment laden, and there is a confusion between the water and the soil. So if we take samples or signature or training from the water and provide it to the software for classification, it will be confused with the soil. So what we did, we use indices such as for water, like normalized difference water index. Maybe all of you, or maybe majority of you are familiar. We use also NDVI to extract water. Both of them, they provide a good output, but as you can see here, if we use the normalized difference water index, we find misclassification in some areas, not classified very well. While if we use normalized difference vegetation index, we find it very good in extracting water. We extract this water and we take it as a signature and we put it in the classification. So mainly we use NDVI to extract water bodies in our study, and then we classify the green areas. As we know that the higher the NDVI, it means more healthy vegetation. Negative values represent water. As you can see here, all this blue color, this is a river extracted, negative. We classify the land use and we achieve 95% accuracy with CAPA statistic 0.92. As you can see from the table, majority is fallow fields. Fallow field, it means temporary, no vegetation. And after rotation of the rainy season, all of this will become like green areas. So classification of the land use here is a problem because during summer, we have a different land use type. During rainy season, we have another different. So depending upon the application, some people may be interested in vegetation, so they can use the rainy season land use classification methods. We classify also the elevation, but here when we talk about elevation, I just would like to highlight the water in Blue Nile come from elevation around 4,000 meters. This is a very high from the Ethiopian plateau. As it comes closer to Sudan, this is dropped to 500 meters, then to 490, up to 400. The message is that from 4,000 to 400, the speed of the water is very fast. So if there is any flood coming here along the Blue Nile, it means it moves with a very high speed. We classify the elevation based on a high resolution digital elevation model. We got it from the municipality of Sennar for this study. We merge all the elevation, land use, and proximity to Blue Nile to rate areas that are at high risk or medium settlement. So as you can see here, all the settlement with this color, they are at high risk because they are very close. Also the risk along the river, red, it means very high, very close to the river here, all of this. Low, the black colors, and medium, all of the other areas. So we mainly focus on the high areas that are very close. As you can see here, this is not same. In some areas may be larger, in some areas may be low, but depending upon elevation. Along these areas, we have many settlements. As you can see, some people live very close to the river due to many reasons, but it is a very dangerous areas that can be flooded at any time. We identify areas that will be affected and impacted by the flood. And we calculate also the total number of population in each area. We hope we are going to provide all of this to the administration there so that they can take action or preventive measures. As you can see here, this is a dam here. So during rainy season, it will be fully flooded. In case there is any something, all of the settlement, as you can see here, this is just down, and here all of the areas down will be affected. Here we use GIS, but we hope in the future to use hydrological models where the models may follow like a wave. That means this wave will depend on many factors. It needs also measurement along the river to indicate which areas will be affected. But in general, we are able to identify all areas that will be affected based on GIS. And here it is an advantage of GIS. That means it can provide a very quick answer to decision makers, to professionals who are not familiar with hydrological models, or they do not have access to hydrological software to do simulation. The other part is mainly we want to identify areas that could be used for rainwater harvesting in case there is a shortage in the water. Because luckily, this year there is a heavy rain in Ethiopian plateau, but in case there is a drought or less amount of rain, we expect there will be reduction in the amount of water. So what we are going to do to have a backup plan, and this backup plan mainly depend on conserving water at the time when there is a surplus in water like heavy rains. We use an index which is well known called Topographic Wetness Index. Maybe you can search online, you will find more detail about it, but it is mainly based on calculating slope, flow direction, flow accumulation, and then determine the values that could be used as a suitable threshold at the rainwater harvesting. So for our case here, we classify the output from the Topographic Wetness Index, and we find the value between 12 and 25 index is suitable as rainwater harvesting, as highlighted here in blue. Some of these rainwater harvesting, they are close to the river, so there is no need to harvest water if it is close to, but it's still, we recommend them as backup in order to store water in case there is overflood in the river. So these areas could be used as a backup for the flooding. Areas far from the river, these are suitable areas, as you can see here. Some areas we find them near settlement, so they may be not suitable. So the area here we digitize, because this is a raster format, and raster format sometimes they have limitation to deal with them. So we digitize like the polygons around each area. So we convert it to vector format. This is a vector format. For vector format, you can add more attribute about where the site, the name, total area, and more description. This description will help decision makers to judge and to put other factors like soil type, like ownership, who owns this site, is it public or is it private, whether it's suitable or not suitable. So based on this, we identify some site, and we hope maybe some of the recommendation could be implemented. How to validate our results? We try to use satellite images, as you can see here. For example, this is provided by the United Nations, show areas that are flooded with this color. So some of our sites that are determined here, it means already flooded, because we need to know from the GIS model whether the data are correct or not correct. Maybe there is no rain previously in this area, so we are going to choose just based on GIS. It may be not suitable. So we use previous flooded areas to validate our results. Some of this satellite rainfall data coincide with our site, and some they are not coincide. We will still verify and refine our results. There is another also output from NOAA on September 2020. And as you can see here, some of these sites, they match with our result, and some they are not matched, but also we find some confusion. It needs more verification. This is what we plan. That means to have like big holes, they call it hafir, where the water is drained, as we mentioned. This is a rainwater harvesting site. This water could be used for livestock, for animals drinking. In some areas, the Ministry of Agriculture will take the lead, and they dig this rainwater harvesting site. They fence it so that they control the usage. Otherwise, it will be spoiled by animals and so on. In our recommendations, we will make more public awareness, and we also propose introduction of some courses or part of the courses in school to enlighten people about floods, rainwater harvesting, water conservation. Also implementation of planning rules, not allow the people to build houses in low areas or close to the river. So all of them are under public awareness. We try also to publicize and to get use of mass social media in data collection, because sometimes there is a flood. So if we find some people take images with location, geolocated images, this will help us to build a database. This database could be used in the future to supply it to artificial intelligence program, because we have a pattern, because what estimation of rainfall from meteorological station or from satellite sometimes may be not accurate, but images from reality from the site geolocated building on different years, it could be used to verify the rainwater harvesting site, and this is well known nowadays. They call it volunteer geographic information. Also, we need more details about socioeconomic data, such as who are live near the river, their economical status, age, gender, and so on. And as I mentioned earlier, we need also to develop a hydrological model using the wave and so on. Also, we suggest for the departments there in municipality of Sennar to use drones, because now drones are very cheap, and it has been already implemented in documenting flood as by Nokia saving lives. So they take image, and these images are very clear. They could be georeferences and kept. So whenever there is a flood in the city, the department can just send their drones, maybe 2, 3, 4, 5, to map all the city with water, because from satellite, especially optical, during rain, maybe there's a cloud, so it's very difficult to get image at that time. Also, the resolution and the accuracy from satellite is less, while from drone is very high. So we strongly recommend using of drones to document previous floods and building a database. This database could be used in any artificial intelligence or machine learning or pattern recognition. So in conclusion, remote sensing satellites provide valuable information, and nowadays become an important part in any meteorological organization. They complement their reading. They find it more cheaper, especially in developing countries where there is a difficulty to have meteorological station all over the country. Some areas may be in a desert, or some areas in a mountain. It's very costly and very difficult. So satellite images nowadays are available free for rain estimation. They can be used to complement rain gauge reading. It could be used for flood, for rainwater harvesting, and so on. GIS provides a mechanism to integrate diverse data, because rain only is not enough to link it with socioeconomic data. So the GIS provide a holistic view. It can be combined with other data to provide better estimation about who will be affected, when, and where. With this, I conclude my presentation, and thank you very much for joining this session. You are now ready and welcome to any question or suggestion for improvement of this work. Thank you very much.
Thank you so much, Dr. Mohamed Yagoub, for your fruitful and constructive presentation. Now, inshallah, we will leave the floor to our audience to ask questions and start the discussions. Let me ask a few questions. Dr. Mohamed, so what are the commonly used satellites for floods monitoring?
As you have seen there, they use the Tropical Rainfall Measurement Mission, TRMM. It stopped. Now they use a GPM, Global Precipitation Measurement, just to estimate and know where the amount of rainfall. Also, there are many models that combine the data and they make it available to the public and to meteorological organization to give them a combination between reading from meteorological station together with satellite. Satellite, not only just the GBM as I mentioned, but they are also NOAA satellites, some satellite from JAXA, and some satellite from European Space Agency. All of them, they combine together and they provide estimation based on models. They are different type of models such as merge models that integrate all of the data from meteorological satellites, from the GBM, and from gauge reading.
I see. Dr. Mohamed, for the flood monitoring analysis, what are the main factors, or let me say the attributes that you took into consideration to develop, for example, the hydrological model?
I think the key is number one is the rainfall. Is that area have a pattern of heavy rainfall during the last 20 or 50 years? So the rainfall is considered the main factor. Second one is elevation. Is this area low or high or a medium elevation? So the elevation and the rainfall are two main factors. In addition to that, are there any people live nearby? Because in agricultural areas, the impact will be less. In desert area, maybe there is no people. In areas that mainly in cities, we find the problem more serious, in cities especially, because we have more concentration of population. So the key is elevation. If we talk about fluvial, that means from the river, proximity to the river, rainfall, whether there is a rainfall pattern, for example. But even in areas, we did a study last time in Fujairah, UAE is considered arid region with low rainfall, but still we have flash floods because you have a heavy rain in a short time. So all the drainage system cannot drain the water at that time. So still, even within areas there is low amount of rainfall, still they can't face the problem of flash flood, mainly in urban areas where there is a concentration of human settlements.
Yeah, we see. Mr. Yasser Uthman, you have some concerns or something to say?
Welcome, Yasser.
السلام عليكم دكتور محمد.
مرحبا أستاذ ياسر. How are you?
الحمد لله بخير ونعمة. الحمد لله. أخبارك إيه؟ طمني عنك.
والله الحمد لله في خير ونعمة.
الحمد لله. Just my question that regarding the TWI technique that you used for determine the area that will be able to receive the extra water in the flooding area. Is this technique based on the satellite or on the elevation, the DM?
Based on elevation, they use elevation mainly an algorithm to calculate where areas that will be flooded.
Yeah.
So it does not consider satellite, mainly based on elevation.
Okay, so it means that this is the only lowland.
Yes.
The use of this land.
Yes.
Yeah. Excellent. Thank you much. This is
Thank you. Thank you. But it is very effective.
Yeah.
Actually, the people, they use it for different studies, for example, to determine bonds. For example, I find one study in the United States, they want to have bond in cities like waterfront for the people. It helps for viewing and so on and so on. So they use it for bonds, but now I use it for rainwater harvesting. It is the same, but for different applications.
Excellent. Thank you very much.
Thank you. Thank you.
Here we have our colleague also from Saudi Arabia, Mr. Ahmed Zubairi, who would like to say something.
Welcome, Ahmed.
Welcome. Thank you so much, Dr. Mohamed. Thank you so much. It's a fantastic lecture, and I would like to ask you about SAR sensors. You mentioned that you choose the satellite imagery where there is no clouds in order to get better resolution. Could SAR sensors, help in that particular issue? How we can get better information regarding this issue? Thank you so much.
Yes. Thank you very much, Ahmed. The SARs have the capability to penetrate clouds, but to map flooded areas, I find some difficulties because of the resolution. Because of the resolution, there is a difficulty in mapping flooded areas. This is number one. Number two, why? Because the timing when it is rain and there the water, the satellite may not pass over that location. So the temporal resolution is one factor. If we are lucky at the time that the satellite pass over that location, there is water, because the water sometimes may not remain for long. Some waters, especially in areas where there is a good, there's a good filtration. Like for example, we had experienced this in Fujairah. The flash flood or the water would remain just for maybe a few hours, and then it disappear. So during this 1 hour, if we are lucky, we will find a satellite image that has a SAR capture the water, so it can be determined. But there are some studies they found matching, especially in tropical areas where the water remain longer. It remain, for example, for 1 day, 2 days. So they have satellite images, SAR, and then they identified the flooded area.
Thank you so much, Doctor. Really
Thank you.
appreciate it.
Thank you.
Yeah, so thank you so much, Dr. Mohamed Yagoub. We came, I think, to the end of this webinar. Thank you all for your kind interest in attending this webinar, and looking forward to meet you in our upcoming events. Thank you so much.
Thank you. Thank you very much. Thank you. Assalamu alaikum.
Salam.